Hi, I'm Travis Newton, and I'm going to talk to you today about internships with NASA Develop being a specific one that I just did, and I'll cover that. But just to talk broadly about GIS internships in general, since I've been in the MGIS program. And I started this in 2018. Prior to that, I was at ASU doing some GIS courses, and I plan on graduating in May of 2021. Here's a general overview of what I'll be talking about, how to apply for this internship, what is NASA Develop, what is your schedule going to look like for the summer, what are the different opportunities that you'll get while you're there, the coursework that I had prior to attending, what my project was for the summer, some of the issues that I found working in this environment, especially in the COVID environment, lessons learned that I would have liked to have known and that maybe you could apply at your NASA Develop internship, and just my thoughts on the NASA Develop in general. So a little bit about me. I did not come from an academic background. I actually graduated high school and went right into the Army. I spent 20 years there. I enlisted out of Salem, Oregon. I keep trying to make it back there, but I retired out of Fort Bragg, North Carolina, and I've been here ever since. And so prior to starting the master's program, after graduating that social science degree, I attended ASU, got some of those GIS and some extra geography courses, and then that kind of set me up for success, understanding the background of GIS. So during COVID, this became a difficult internship summer for applicants, just in every field, but GIS as well. I applied for 5. I didn't get contacted or was overqualified for 3 of them. 2 of them were my primary, which was my hometown Salem, Oregon, and then NASA Develop. Both these were quite different in how they were going to unfold. One was in person, one was virtual. One was a project and based, and the other one was more working on applications and just contributing to the current workload that was already in existence. For the NASA, you can see on the bottom how it kind of unfolded. As far as the timeline goes, there was only 1 round of interviews for them versus 2 interviews for Salem. By the time Salem got back with me and offered me the position, I had already accepted with NASA, and it was going to be virtually. I wasn't going to have to drive 3,000 miles. There was a very short time window from end of semester to actually having to be out in Oregon, and NASA just made more sense anyways. All right, so the cover letter, I included information about myself, my previous employment in the military, which then gives me veteran preference. And then I had a previous internship to the Cook Islands where I did remote sensing, and so I included that. So I showed GIS work, my last semester's coursework and current coursework, that it could be applicable to a remote sensing field. My resume is not over 2 pages, and I recommend staying with 2 pages unless you have an academic CV where you have a bunch of journal articles that you want to discuss, or that you've contributed on, sorry. Then you're going to get 3 recommendations. I looked at my professors, the GIS director, Dr. Money, Dr. Nelson, who does remote sensing, and then Dr. Supak, who I also was a teaching assistant for. You'll have 7 essay questions, and those are on the application page, so you'll just copy those, form like 200 to 300 words, and how GIS can be applied to it, or your experience in GIS and how you have dealt with the situation. And then interviews, I just did a Google search and hey, what does NASA Develop ask for interview questions? So I think I had maybe 10 or 15 different questions I found on Google, and then formed responses for those. And then, so the Develop is run 3 times a year. So that's an excellent opportunity after graduation, because it takes a while to get hired. If you're looking for a federal job, it takes a while to get hired. And so you could spend up to 6 months waiting around for a federal job. And so in the meantime, you can apply for a NASA Develop internship, get federal experience, and then roll right into your new federal job. So Develop and 2 other agencies, RSET Severe, fall within the capacity building program of the Earth Science Division within NASA. RSET deals with training remote scientists in the different tools that are out there. And so you could look at MODIS for soil conditions, and you're going to use Google Earth Engine API or use QGIS. Now, develop, they're partnering students or just recently graduated students with a partner force to solve an issue. And then Severe is located around the world, 3 different locations, and they work on just larger global projects like climate change, pollution, forest degradation, and items like that. Now, for the develop, I can just read you the mission statement, which kind of sums it up, which is integrating NASA Earth observations with society to foster future innovation and cultivate the professionals of tomorrow by addressing diverse environmental issues today. So it's a very broad range. My NASA developed location isn't a typical one that you think of. Everybody's always like, oh, you're at like a space station or a space launch pad, which we were actually teamed up with a NOAA location, and within NOAA we were at the NCICS division, which is the North Carolina Institute for Climate Studies, and that is based out of Asheville, North Carolina. But there is NASA developed hubs all over the U.S. Here is the Earth Science Division breakdown a little bit more. There's 4 lines of focus: flight technology, research, and the applied sciences. The develop concentrates more on the applied sciences, and I'll just kind of read that bullet. You're welcome to pause and read the rest of this stuff. But applied sciences support innovative and practical uses of Earth observation and scientific knowledge by private and public sectors to inform their planning decisions and actions. So at the end of your summer internship, you're going to have a week called Applied Sciences Week. And this is where teams of interns, or if you're a single intern, what your project entailed and how you went about solving it, and lessons learned and your scientific outputs. Now here is a typical NASA work schedule you can expect to find yourself on. And now this is all according to the COVID-19 rules, right? So my month after semester ended, I found myself very busy. Now trying to do RSET modules, NASA software carpentry, Esri books, Esri online training, as well as I was moving 2 households, and I also went on a short vacation to Florida. So it was a very busy month. Once you start 1 July officially, or I'm sorry, 1 June, you'll log in on Excel, log your 29 hours a week, but expect to do at least 40 hours a week and then flex to 50. And for me, I did that because there's a lot of new tools I was trying out, such as like random forest regression and learning that and trying to get it to work. I'll go more into that later. Daily battle rhythm, you can expect to start at 08 at your computer. Now this is big boys rule, so just be at your computer. If you're not there at 8, stay a little bit longer in the day. 9 to 10, we had a daily meeting. At 1 o'clock, we'd have an afternoon meeting. Every Wednesdays, we had an NCICS coffee hour where you get to meet some of the other employees. And then on Tuesdays, we're a brown bag lunch and learn where a scientist for that week within the NASA Develop or NOAA or NCICS would give us their spiel on, from college and how they got to where they are now. And there's a lot of them are doctors, a lot of them just have master's degrees. And so you get a mix of people that are, either earth science or data scientists or GIS personnel. There's just a mixture of people that gave brown bag lunches, so it was a good opportunity to pick people's brains. All right, here are the different NASA deliverables you will have. These aren't really in any order, but at the very first week you'll have an admin week where you have just different assessments, and you do your participant web page, so everybody can look you up later on. At the very last week you'll have some more stuff like exit surveys, just a bunch of assessments and how did the internship go. And then throughout, you have the rest of this items. So you have a project summary and a technical report. Both these will have rough drafts, due week like 2 and 3, and then final drafts due in week like 7, 8, 9, somewhere in there. You'll have a presentation Applied Science Week. This is where all those interns get together and they showcase their skills learned in the summer and their science outputs. You have a presentation for your partner force, but you expect to have presentations throughout. We had a presentation every 2 weeks, but then we had one final one that just kind of closed the book on our work for the summer. You get to choose either a story map or a poster. We chose a story map. If you choose a story map, then your video gets to be a little bit shorter. So we did a 30-second video, but if you do a poster, you have to do a minute video. You'll have a study area shapefile. You'll zip that, upload it to the website. You also have a website image, and the website image that we actually built was the very first image you saw on this slideshow, which included an NDVI, a normalized difference built up index, and a normalized difference water index. That's what I put together. And then you have a Developpedia web page, and on that web page it talks about all the different sources that you used, what your project was about, summary, abstract basically, and then you'll have some of the pictures of your work on that website as well, and then like links to where you got the data and such stuff. All right, here is our NASA calendar, our 10-week calendar going from 1 June to 8 August. During the first 2 weeks, you'll do the in-processing, the orientation. We did software carpentry, total of 4 sessions, and those were twice a week at 8 hours a pop. Week 1 was Unix, week 2 was RStudio. We had our partner meeting on week 2. It was very ambiguous, we kind of had an idea. We were going towards looking at evergreen trees and some hemlock declines. We weren't quite sure how to do it yet, and it took another meeting to get some more information. So we started collecting data, based off of what we thought we were going to do. But in trying to narrow down a boundary for our study, it took us a while to do that too. So then we had to always go back and look at more data collection. During week 4 to week 7 was our big data processing, and you see like we had 2 weeks of heavy data processing, then heavy 2 weeks of data processing / data analyzing. And so really you only have 4 weeks at NASA to run GIS data, because you've got to plug all this information in week 8 through 10, where we were doing finalizing the analyzation, trying to build charts, whether that's in Excel or RStudio, and I chose Excel just because I was familiar with it from a stats class, and then working on producing your final drafts. And all throughout here you have briefs and all sorts of admin tasks that slow down GIS work. So when I talk about hours worked and be ready to work over 29 hours a week, that's because there's a lot of admin tasks that you're going to have to do all throughout this time here. So your time's going to be spent on that Friday day off and then on the weekend trying to get some of this information complete. All right, 3 main points of NASA opportunities: 1, networking; 2, career advice; and 3, other projects. So networking, it's very difficult. It's COVID, so everything's virtual, and you just don't get that in-person connection. But you do get a chance to show your face and ask questions and just put yourself out there to the science community and the federal government in general. LinkedIn, you get to connect with different advisors, and so you start building this social network in the workplace. I talked about those brown bag lunches, got to hear their different stories. And then other projects, when I say it gets to lead to something else at the very end of it, one of my science advisors, we had 2 on our team, introduced me to FTAC, which is the Eastern Force Environmental Threat Center. And now I'm going to partner up with those guys and start looking at landslides for this final year. I'm going to try and collect some information in 521 surface hydrology, and then throw that into a final systems application for the final project. Here is my coursework on the left, completed prior to starting NASA Develop. On the right is what I have remaining in my 3rd year. I took 3 years because the military is paying for it. I'm a veteran, and it gave me 2 internships prior to going into the workforce in this new career field. Prior to this, my introduction with maps was more land navigation and battlefield assessments. So it's kind of a different world, right, from major science aspect. Of these courses, the most important for my particular internship with the EBCI was going to be the remote sensing, because it worked with Landsat, understood the spectrum, how to do land classifications, spatial problem solving at GIS 520, dealing with raster files, model builder, and particularly weighted overlays. I ended up using that in the final output. And then hydro modeling with the SRTM data and GIS 582. But all of these had their own importance. Like 540, just understanding a baseline for coding, although we didn't use it because NASA has a code approval that they have to go through in order to be released. So it could be up to 6 months before EBCI would have saw any of this work. So we opted for the model builder and building a tutorial system, because they didn't have a GIS program currently at their natural resource department. So being able to give them any tools that they can do the work on their own without a GIS person was important. Looking at like geospatial professionalism, how to do a different technical report versus a layman writing. And if you look at the project summary, that would be the layman writing, and then your technical report obviously is technical. I remember at one point, one of my technical advisors bringing up moving map window. And so it just goes to show, even though I didn't use, techniques really from 530, but understanding the application when another science professor or professional discusses a technique, you have a baseline to understand what he's talking about. Like, oh yeah, I remember that in Dr. Supak's 530 class. And then, just having a prior internship, working with younger people in a civilian capacity outside of the military was important to work in this virtual environment with other NASA scientists. But all these courses were super beneficial. So a little bit more about our NASA team in general. We were under the NOAA node out in Asheville, but within there is a NCI branch, which is the North Carolina Environmental Institute, and within that was that NCICS, North Carolina Institute for Climate Change. And all this falls underneath the NASA flag. Now, we would remote in every day, we would do the teleconferences, and those would be held either by Microsoft Teams or Google Meets. Here was my 5-member team. You have a NASA fellow at every node. So the NOAA node, our fellow was a geoscientist. One member who had done this previous, he was out of the Marshall node. He's a biologist. Member 2 was a environmental science and geography. She had just completed her degree in UNC this year. The other member, environmental science, computer programming. The computer programming is very helpful. He took on some other GIS tasks, and then myself being a social scientist and GIS personnel. File sharing would be through Microsoft SharePoint or the Teams. And both those are connected together, so you could drop one on Microsoft Teams that would show up on SharePoint and vice versa. And then in GIS, we had the VCL, much like we do here at NCSU, except for trying to drop that on it takes a little bit longer, and then you have 4 people mess around with folders, and so at some point you're going to end up getting something corrupted. So we had one geo database that got corrupted and was unrecoverable, and it had all of our USGS Earth Explorer Landsat data that we had collected, mosaicked all together, and boom, it was all gone. And so we ended up having to revert. We went to Google Earth Engine and ran an API script to download everything else, all the stuff we needed in the end. All right, so I'll briefly discuss the project summary. We were working with the Eastern Band of Cherokee Indians. Our title for our team was Cherokee Water Resource Team, and here's our study area. You can see where the Eastern Band Cherokee Indians have land. It's quite spread out, but their main Qualla Reservation is that orange up in the top right there you see, and it falls within the Oconaluftee watershed. You can see the legend below it. And one of their main goals, is just to capture what Earth observation platforms can do for their natural resources department and how it impacts the quality of life there. They don't have a GIS person working at the natural resource team. They only have one GIS person or two, I believe, within the entire reservation system. One being dedicated solely to land parcel management, and then one working for the 911 operations. And so they don't have access to those. But they do have access to Esri, running ArcGIS and having ArcGIS online accounts, and also some pro. But their licenses are limited, so we're showing different licenses and how they work within the Natural Resource Department to discover or use Earth observation methods. And so by doing all of this, showing the tutorials, showing the capabilities, it allows them then to write reports and get funding for a GIS person within their department. All right, we looked at multiple ideas from multiple sources. Everybody's got different ideas because they come with different backgrounds, right? We have 4 departments within the EBCI's natural resource team. And that could be like water, that could be forest, it could be the endangered species, could be the communications department. There's lots of different departments within any natural resource team, right? We had 1 fellow lead, we had 2 science advisors, and 1 with a background in forestry, 1 with a background in climate and data analyst or data programming. And then we had liaisons out there at the National Forest, the Great Smoky Mountains, as well as a liaison with the Hemlock Restoration Initiative. And that's a civilian organization. And then we had team members within ourselves. You saw our different backgrounds. And so all these different walks of life have different ideas. In the Army, we call that the good idea fairy. Everybody's got one, and then they always like to expand on them. So you really got to focus and channel your ideas into one output, right? And then here's different categories and different subcategories we looked at. It could be everything from forest fires, stream quality, air quality, measuring tree canopy, and how does that tree growth with LiDAR or DMs, logging, endangered species, you name it, we discussed it. All right, we narrowed down our questions based on time for the study, just to the 2 on the right. Our boundary continually changed throughout the first 4 to 5 weeks. We started with a small box around just the Qualla boundary itself, and then it just kept migrating larger and larger until our very end, where we had all the watersheds that encompassed all EBCI lands, as well as the Great Smoky Mountains. So we could draw data from there. And the boundary box ended up being across 4 state lines: Georgia, South Carolina, North Carolina, and Tennessee. We did lots of statistics on other information that we didn't do in the report, just due to time, or the outputs just were not jiving with what we wanted to show. We did a 20-year time change between 2000 and 2020. On that 20-year time change, we were showing evergreen loss across the EBCI lands, across all the watersheds that encompass the EBCI lands. We worked heavily on random forest regression analysis to identify hemlocks, both with human and environmental factors, as well as just Earth observation platforms, just to see if we could identify using those methods, because there's a host of different raster functions that you get with imagery analysis licenses. We also looked at fuzzy membership, but just ran out of time for the project. Now on the NDVI winter change, here was our question: where has winter NDVI declined in evergreen and mixed forest between 2003 and 2010? We just stuck with that time period and used Landsat 5 because the sensor was different between that and Landsat 8, and it takes a lot of time to do sensor corrections between Landsat 8 and Landsat 5. And then Landsat 7, the scan line corrector has failed. If you've worked with Landsat 7, you've seen that output, so we stayed away from it. We did an average difference on this winter decline and came up with our outputs for the O'Connell-Leffey watershed, which is the watershed that mostly encompasses the quality boundary. And the weighted suitability analysis, this allowed us to do both human and human factors, environmental factors, topographic factors, and put everything in there to try and find the most suitable locations. And I'll talk about that in a second. Here's one of the main outputs for the NDVI winter change signal between 2003 and 2010. We got to this by using all Landsat 5 data. We took two years, so we took 2003, 2004, added those together, and then divided them by basically like two. Got an average for these two winter signals, and we got a average between a 2009 2010 winter signals. Then took the difference of these averages, used a standard deviation model to find out where the change was happening. We saw that the change was right skewed towards decline in the evergreen signal. As you can see, all that red up in the upper right, and that's where predominantly all the evergreens were. Down lower, it's much more deciduous mixed. But this O'Connell-Leffey watershed was mostly in forest canopy anyways. What was the difference in the canopy cover? We saw the decrease mostly around the stream areas, and we know that that's where the evergreens predominantly live, as well as when we do our hemlock identification, we can see hemlocks are mostly within those streams as well. All right, so on to the weighted suitability analysis, where we're looking at doing multiple variables with a single category and multiple variables with multiple categories, just two different ideas of a kind of the same approach. And we're out there trying to find these hemlocks. And why are we looking for hemlocks? Well, because this is a tree that's important for the reservation and in the forest in general. These trees have historical, or not, but cultural significance as well as environmental significance. They cool streams, they provide moisture that adds to the water quality, that helps dilute any type of pollution, which is better for just land in general, better for animals migrating, fish, reproduction, a bunch of things, not the environmental, some of the GIS personnel. But we know where these hemlocks are based off of treatment polygons that we were able to get a hold of from the Great Smoky Mountains and the Hemlock Initiative, or Restoration Initiative. So they've gone out and they've sprayed for this bug called HWA, hemlock woolly adderlage, that just feeds on the limbs of the tree and eventually kills them. You saw in the last picture where there's a bunch of dead trees. Well, those are dead because of the HWA. Now, what happens when you have a forest that's already dry and you have even drier trees that are dead? Well, it produces forest fire. Well, it doesn't produce forest fires, but it helps the forest fire. These things go up like tinder, right? And when you have forest fires, then you have poor air quality, and that feeds into, you have less trees to help catch sediment, and that goes into the water. So all sorts of things all sorts of good comes from having live, healthy hemlocks in your riparian areas. So we want to go out and find them. We want to help treat them and save these hemlocks that are out there for the EBCI. So we were able to get values by extracting a series of points from these polygons, taking an average of those, and then looking at those averages for these different watersheds for the EBCI. And so we just did a baseline test on the O'Connell-Leffey watershed. So here I show the multivariable, multi-category. How do you get to all this stuff? Well, your main tools that you use for data like this, you use reclass, you use extract multi-point values, raster calculator, weighted overlay, Euclidean distance, all tools that are used in both the multivariable, multi-category, and a multivariable single category. And in the single category, I basically just said, hey, what is the highest of this high probability within this output map I show here. So basically, you're guaranteed you're going to find a hemlock in that one that's not shown. But here you get a much broader range that you can see. Okay, well maybe there's moderate area for hemlock, and the reason that this thing is so large, as you can see over on the right, that most, like I think 97 or 94% of this watershed is actually made up of forest canopy. And you can see on the right hand side where we've overlaid the hemlocks with the different forest canopy. And when you look at this in general, you're like, oh well, 54% of this watershed is deciduous. But then when you normalize the data, you're like, well, hey, 26% of the evergreen within this or evergreen forest within here contains hemlock, according to these outputs. So now, understanding your data is super important. So the main way I made sure I stayed on track was, having everything as a vector file and calculating geometry from there. So hey, I know exactly how much, because you can't really screw up any of your vector data when you're calculating geometry, right? It's pretty straightforward when you're dealing with Esri. And so having that baseline, you're able then to use all your raster data and use, tabulate areas, zonal statistics to get your different outputs, right? And then you've got to make sure your math is correct, and then you compare it against your vector geometry. If it's right, then good, all your data is correct. If it's not, then go back to the drawing board because maybe you use the wrong unit of measure. All right, we're going to discuss issues now. There are a lot of them, and I bring them up in order so when you go to NASA Develop as an intern, you'll be able to be ready for them and how to combat them. And some may not even apply by the time you get there, right? So first off is our VCL. It was inadequate for Arc Pro. Now, as a GIS person, we have GIS 550, and in there, you get to learn about, or you set up your own server. On that server, we had 16 gigabytes of memory, and it was barely enough to handle ArcMap. And so now when you move over to Arc Pro, it is memory intensive, it's video card intensive, and so we're trying to run that on it with only 16 gigabytes. Now, as Esri says, you can do it, but let me tell you, it is slow. And now you try and move to machine learning, forget it. So I requested an upgrade to 64 gigs. And that allowed me to compare force regression analysis, the outputs I was having between my machine and the VCL machine. And now, was the outputs a condition of my computer or is it a condition of my tools and the inputs I was putting in on the tool? And I was getting the results back on both machines. So it was something that was with my inputs, or just the way that tool read my inputs, right? NASA isms, so there's no writing on maps. If you're a cartographer and you love maps, you love to see them, it's really going to drive you crazy because you can't put anything on your maps. You can't put any words, you can't put any legends, you can't do anything. You just make your map with your data and you put it into PowerPoint as a JPEG, and then you add all sorts of like little blocks and you do everything super time intensive in PowerPoint. It'll just drive you crazy. No code deliverable to partners without a software release. That's NASAism. And that's not an issue to me, but it's something you'll deal with if you're a big computer programmer and you really want to write code for your project. We use Model Builder so we can side skirt that problem. Now, US Earth Explorer, it was going through an upgrade during our time there. So it was down for a complete week. And we were trying to resource other areas. Finally, it came back up. We got all of our data. We had it all mosaiced in that geodatabase. Geodatabase got corrupted on the VCL. We transitioned back over to Google Earth Engine, wrote an API script. We were able to, there's two different API scripts, or the API script is different for every type of remote sensing platform that's out there. And so we were able to get both Landsat 5 and Landsat 8 data in the study area we want without having to do any mosaic. Came cloud free, and so I recommend, for large projects and large, especially large time studies, that you transition over to Google Earth Engine just to get that remote sensing data. Virtual internship, when you work with non-GIS personnel background, it's very difficult to discuss the tools that you want or just collaborate on different ideas with GIS. And that is just a virtual internship. Like, it would have been solved had we been in person, and we could have had like a round table, where you have, all your laptops off, you have whiteboards, you're drawing things and writing ideas, and somebody has a question, you're like, hey, can you guys process this? I'll process that. It works much easier in person if only one of you has a primary GIS background. Random forest and regression analysis. As you can see here in the pictures, on the top right, it is over predicting, and then on the bottom right, it's repeating sections. This is what I was trying to talk about before, where the top half reads and then it just generates that same output for all three. And it was super frustrating. I would change different inputs, and then I would still get the same stuff. So it's going to be a continued working process to learn how to use that thing correctly, and maybe it'll work differently for different data. And I hope to try and use it with some of the landside stuff. Next is PowerPoint rangers. That's a kind of a military term that we have, and we call those PowerPoint rangers are people who spend their majority of their Army career doing PowerPoint instead of out in the field doing combat operations. And so instead of doing GIS operations, we did a lot of PowerPoints, and it seemed like we were doing PowerPoints to brief for other PowerPoints. We were briefing an advisor, we briefed partners, we brief each other, and it just became a constant stop what you're doing, build a PowerPoint slide. So it detracts from actual working GIS. And that's where I'd say, hey, you're going to end up working more hours on the weekend if you're the sole GIS person, because you spent your week building PowerPoints. And then there's mandatory software carpentry. And that's shouldn't be an issue, but here was our problem: is we learned Unix our first week and our statistics our second week. We didn't use either one of those for our study. And then our statistics we could have used, but there was nothing that was GIS related to our statistics tutorials that we were given until like the last 20 minutes of the second 8-hour day on our statistics. So that was kind of frustrating. And then there was one other thing I wanted to discuss on VCLs. I'll think about it on the next slide. All right, lessons learned from the previous slide. I'd also like to mention, having Arc server would have been a huge benefit instead of trying to drop all of our data on the VCL when we're sharing or collaborating, with your different data. Because I always worked on my personal machine versus VCL. It was much faster on my machine, but then I would have to take all of the data that I processed and then put it on the VCL so everybody else had access to it. So then having, being able to version your files and stuff like that, if somebody deletes it, then you can recall a previous version, would have been beneficial. But, working in an Arc Pro environment, you have to have enterprise, and then that gets very expensive. So then that's why Arc servers just not run, right? So here's some other lessons learned. Virtual internships are difficult, but, if you come from a scientific background, you're going to be A-okay. I survived. I don't come from a scientific background, but I work hard. NASA Develop, they're mostly interested in scientific charts and data points. So keep that in mind when you come to work here. Is you're looking for hard data, right? You are a scientist. You're not a cartographer. You're not a web designer. You're not out mapping hiking trails or anything like that. You're here to quantify data. Engage partners from a business perspective. I think this is one of the key takeaways that I thought about it towards the end of the internship. We went in, asking questions, trying to get information on what the EBCI, what they wanted us to study. And, because everybody has different ideas, it felt like we were always kind of swimming in the ocean. So this is how I would kind of approach it from like a business perspective almost when you start dealing with partners, and it could be not just the EBCI, but any type of partner, right? Is, ask those different departments that you're working with, hey, everybody have a concern, bring an idea that you would like to study. So if you had 4 departments and each one has 3 different ideas, well, now you have 12 ideas, and then you ask them, hey, of these ideas, give me 3 ideas of your 12 that you think you could take to a city council, a tribal council, or a state congressional committee and get funding for. And so that's really going to help you say, oh, this is very important, and then come up with an idea of those 3. Maybe you just pick one of them, or maybe you end up looking at a hybrid of 2 or 3 of those ideas. And when I say the hybrid, maybe you're not really looking at one, but you're studying one and looking for regression analysis based off the other 1 or 2 ideas. Pick systems that everyone's familiar with or no one's familiar with. All right, so if we look at ArcPro, I was mostly the heavy guy for doing this, but then I'm always doing all the work, right? And then it's hard for me to then share all this information. Now, that being said, the whole project is a team collaborative, and so there's other stuff that the team members are doing. But I think, as you're collaborating with the team and you're trying to develop your skills, right? Picking a program to do all your data that everybody can learn mutually, I think is probably more along the lines of how develop should or wants to operate, right? And so for this, if I had to go back and do this all over again, I would have said, hey, let's learn Google Earth Engine and our statistics from the get-go. And then we could have maybe the team could have collaboratively said, hey, we're going to drop Unix and we're going to go with learning API JavaScript during those 2 sessions. And then on the R statistics, trying to do some more research with books, YouTube videos, whatever. And I would say even more important is having thought of that idea, studying that your month prior. You drop everything that you're doing the month prior and focus on those 2 methods. All right, next is having different types of internships. Teaches GIS students what they like about their career path. And so now, looking at all the different internships I've had, I've only had 2, but one was for the Cook Islands. I got to go, map hiking trails, collaborate with the team, write stories for a book on different, how I thought the trails, basically a hiking guide. And I really enjoyed that, and the cartography that went with it, and being outdoors and getting to do field work, and that's super important. I know I do not want to be stuck in an office jamming GIS data all the time. I want some type of field work, and whether that is going out on a trail to find something, whether map a trail or find a problem out in a forest, maybe going and flying UAV collection, to update the imagery for a department. But I cannot sit in an office doing virtual work or just being in an office for a long period of time. I really would like to be outside. And then be assertive on your GIS realizations to non-GIS members. And so I think at the very beginning of this exercise, I said, hey, we should look at only, if we're going to look at 20 years, we should stick with 5-year intervals, and that'll give us only a few year points to deal with. And instead, we really stuck to our guns on the 20-year stuff, as well as increasing the size. And I was like, bigger the size, the more data you got to collect, the more mosaicing, the more issues you run into, more clouds you have to deal with. So a lot of that, you keep your area as small as possible to eliminate issues with your study. All right, so items I would do differently. This is a build upon on lessons learned from last slide. So the coursework that I focused on for that month prior to joining was the RSET training. I looked at I pre-did some carpentry software on Unix and GitHub. Books, I was working on HTML, didn't use that, but I was just kind of getting a baseline into CSS and API. I read an Esri imagery book, get refreshed on that, and also during the first 2 weeks, I finished that book. And The Esri courses, I looked at database stuff initially in my first week after the semester, just because I was trying to capitalize on lessons learned in 550, as well as doing some model builder. And now I would change all of that coursework I was doing. I would keep a couple of those RSET courses, but then I would go into the Google Earth Engine API scripting tutorials. There's just a whole bunch of them, and you just get practice, working JavaScript and understanding what it is that Google Earth Engine is doing that's comparable to Esri products. Gears is also another website that does Google Earth Engine. And you can pick up all sorts of different ideas as you're doing these tutorials. You're looking at forest, you're looking at water, you're looking at air quality, all sorts of environmental issues that you're learning, and you can bring forth to the intern problem. And then our statistics, these are the two books that I would look at. Both have pictures, both have code. Now the one on the left is an intro to R, so I would do that one before you do the geocomputation with R. I've only done, I think, one chapter of the geocomputation with R, just because I happened to get that book in the mail prior to the intro to R, and so I can't really elaborate on the quality of either of these books, but because the ones in intro, I would start with that one. So some reflection on my NASA development internship, and I can pass these reflections on to you. When should you do a NASA develop? And my recommendation is after your second year, going on to your third, or if you're only doing a 2-year term, then you do it immediately after after graduation. And if you do it right after graduation, well, then that gets you your foot in the door for a federal job once that internship is complete. Also, doing it after your second year, if I had done this after my first year, I wouldn't have had the requisite skills, that I gained in 520, 582. My coding, out of 540 just wasn't that good. Having a computer programming background, elevates your ability to understand just computers in general, right? So I'm still working on that. Having never done this, or would I do an NASA develop internship again? If I had never done it, absolutely. I'd be a little bit hesitant of doing it virtually just because you don't get that in-person collaboration, but I would absolutely do it, because you're learning something about yourself, you're learning skills, and you don't get to replicate that in many other internships. And so NASA really brings that science background and collaborating, writing reports, and just doing all the different things that you may find yourself doing within the federal government, other than just processing GIS data, right? Or having done it once, I wouldn't go do it again because, when you graduate school, you have the skills that you have, and it's time to go get a job. It's not time to be an intern and working for low wages, right? Sure, coming out of a GIS program, you can expect, some low wages, because you're starting off at the bottom and working your way up, but it's definitely not going to be intern wages, right? You have a master's degree. So, let's see. So what did I learn about myself? I enjoy the field work, I enjoy cartography, and I enjoy bringing a functional product to bear that people can use. Whether that is a web application or a map that they can feel in their hands and navigate their areas. And so, being in the Army, I worked overseas most of my career, and I worked in Southeast Asia, Oceania, and so I get to always work with, small populations, who sometimes were underprivileged, and I'd like to go back to doing something like that, where I can go and do some small database maintenance, do UAV collection, help them run GPSs to map their own buildings and the roads, and bringing that all together into, an electronic platform or, analog platform that they can then, make their area a safer, cleaner, healthier place to live. And what I don't like is definitely virtual networking. unless you're doing it in a platform where everybody's on the same page and you all come from the exact same background. Then it makes conveying the different techniques that you guys are doing that much easier. But if I were to work from a virtual environment, I'd much rather work alone on a problem and without interruptions. So here I'm going to compare the different internships. I threw the last one on that I got accepted. Although I didn't do it, but I just threw it on there as a different type of internship, right? So my first one was over at Global Truck Adventures. We got to go to the Cook Islands. I got to hike outdoors, map those trails, got to scuba dive. Then we got to publish a book, making these cool hiking maps. Backpacking is my pastime. Got to fly drones, got to experiment with how to do coastal mapping, swimming out and weight, putting buoys in the ocean, then problem solve. There's a lot of problem solving there, trying to get data because SRTM and ASTRA data in the Southern Hemisphere is way off. So I had to overcome that. It was fun. And then you get to work in a team environment with young people, and it helped me do a real world transition from military life to civilian life. Then at NASA, right? So this was a remote from home, so first I got to go overseas. Now I'm stuck at the house and not being able to go anywhere all summer, because I'm just tied to a computer. But you get networking there, you get federal employment, you got to look at all your scientific analysis. So you're really quantifying that data. You got to have the statistics background. You get to do, your research in GIS, problem solving. You're working with a collaborative partner. To find out what their issue is and bring a solution to the problem. You got multiple deliverables and timelines that are tough to meet, but they're also fun, right? Because it's fun to meet challenges. And I put in red here, and that's the biggest takeaway when you get a NASA internship at Develop, is you get a NASA stat. So no matter what, for the rest of your life, you can say, I worked at NASA. You can put your hands on your hip like you're in charge, or you're Superman, right? You got to work at NASA, and everybody thinks you're an astronaut, right? And then looking at the last one, which would have been back in Oregon, it would have been more GIS centric, processing whatever they had for me, doing database management and doing like a lot of repetitive skills, because that's really how you learn through research, but you also learn through repetitive tasks. So if I write a code, for hydro modeling, 20 times. Well, by the time I get through it on the 20th time, I should know what I'm doing, right? I would have got to do some web design, some cartography, possibly some UAV work, because I'm also Part 107 Alpha qualified. And then I would have got to work in person. And then my last little tidbit on that is location, right? Because if you've never been to a Pacific Northwest summer, there's nothing else like it on Earth. In the background, you see Mount Hood there. The way forward, I put this slide together is what am I going to do with the knowledge of 2 years worth of GIS? How am I going to apply it to my third year? And how do I take those internship knowledge that I already have? So atrophy is my first bullet. Use or lose. I haven't got to fly my UAV in over a year. I know one of the FAA websites to declare a NOTAM has changed. That's how long I've been out of it for. Maybe possibly collecting some UAV data for the 517 landscape architecture, as well as trying to incorporate Python scripting into my homework assignments for 521. I think week 2, I was able to write some scripting in Python Pro using these 2 books. I got this during the summer, and I got to practice it the first 2 weeks of school here. But I've transitioned out of the Arc Pro. I found it not as user friendly, and I've kind of gone back over to 2.7. So I'm using Dr. Tadeusian's Python book. It's very big. Can be tough to read if you're new to Python, but there's a lot of great information in there, as well as David Allen. And I tell you, everything that David Allen touches in GIS is gold. Like every single one of his books, if its name's on it, you can guarantee it's going to be a good tutorial, and you're going to learn some information out of there. So I'm using both those books, going back to ArcMap for my Python scripting. Because I also feel on the final project that we're going to use ArcMap, because you got to use ArcServer, you got to do a database, and so you're not going to be able to incorporate your ArcPro Python scripts. So it's better just to go back and do it for 2.7 for the meantime, until such time as when ArcPro Enterprise is up and running and you're writing scripts for that. I also got myself a Dell R710 server. I bought it off Craigslist to use. I'd like to try and set it up and learn how to run it backside. Because later on, I would like to take that whole NASA project I did in ArcPro and convert it over to Q and GIS. There's a plugin that connects both those together, as well as the do the R statistics and do some Python coding and have everything run on a open source software. So that way you can take these techniques. Like the last time I was talking about, going to Borneo, right? Well, you're not going to take an Esri product, that costs thousands and thousands of dollars to a developing country and say, hey, I got this great idea, build this. And then PhD versus MGIST within industry. And this is, for anybody, I just kind of put it out there, PhD, if you want to chase a PhD, expect to work in university life or be a professor or work somewhere that is very heavily an agency that has a lot of PhD centric people, and that's going to be USGS or NASA itself, maybe some NOAA as well. But then the MGIST program, you take what your lessons learned from there, and then you go and get your GISP, your professional certification, or your ASPR certification, and then if you have a master's degree and you got either a GISP and an ASPR, you're going to be able to work any job you want wherever you go. And so that is where I'm going to start focusing my attention is on there, because that'll allow me field work. Because if you go into the PhD realm, get ready for sitting in the office. Once you got that PhD, you're not getting out of academia or out of the office of one of these other federal agencies. All right, so final thoughts on the NASA. Hope for a COVID vaccine. Once the COVID vaccine comes, you get rid of virtual internships and you go back to working normal internships at NASA Develop. These virtual internships started halfway through spring 2020, and you expect them to continue all the way until COVID's done with. Until we have vaccines are mass produced. And so keep in mind, though, that many internships have stopped due to COVID. I remember, listening to all students, not just GIS students, but students in general, they had no internships. They all got canceled due to COVID. They couldn't work in person, and they just didn't have a virtual network set up. So I would encourage all MGIS students here at NCSU to apply for the NASA Develop. Granted that they have either they've completed the two years and got 520, got 582, and got 512, or they're starting the MGIS program, but they work at Esri, they work at some other GIS job. I know one of the TAs, Allie, who many of you guys probably know, works down at Esri in Charlotte, on all sorts of different functions within inside Esri. So somebody like that, if obviously they weren't working, could work directly for this NASA internship without having some of those courses. And keep in mind your future career path. Do you want to go on the science side, or do you want to be an analyst, technician, a manager? I kind of lump all three of those into a category. And that's where your MGIST degree comes from, or the PhD, for the scientific research side. But at the end of the day, your job as an intern is to diversify your resume. And so, do you want to say, hey, I worked at the city of Raleigh or the city of Salem, or did you work at NASA Develop? All right. And so what's going to carry more weight when you submit a resume and you have two interns who have the same qualifications from NCSU, we'll say, and this same job previous background, but one has an internship at the city and one has an internship at NASA? Which one carries more weight? And that is the end of the presentation. Here is a link to NASA Develop. I encourage you all to go out there and use remote sensing, Earth observation platforms, and discover problems with the Earth. Have a good day.